Imagine a creator team sitting down to produce a week's worth of social media content. They start by submitting a single brief through a familiar interface. A text description of the idea, maybe a few keywords like summer travel hacks or quick meal prep tips. Within minutes, the system springs to life. It generates a script, selects visuals, adds captions, creates voiceover, and assembles everything into a polished vertical video optimized for TikTok, YouTube Shorts, and Instagram Reels. Short clips are extracted for teaser posts, and all assets are ready to publish with one click. This isn't a futuristic dream, it's the automated content studio built by combining 5 specialized tools into one seamless workflow. Here's how it works. The user input is simple: an approved brief with basic creative direction. The output is a full suite of multi-format content, narrated videos, captions, clips, and publishing metadata, all derived from that single input. There's no manual editing, no juggling between apps, no waiting for renders. The system handles everything from ideation to final assets, turning a chaotic creative process into a repeatable pipeline. Under the hood, this product relies on a carefully integrated stack. YumCut acts as the content renderer, transforming the brief into a complete short-form video. It uses AI to draft a script, match visuals to the narrative, generate captions, and stitch everything together into a 9:16 vertical format. VoiceBox steps in next, handling all speech-related tasks. It converts the script into natural-sounding voiceover using one of its 7 TTS engines, allowing for expressive delivery with pauses, emphasis, or even simulated emotions like laughter. The voice data never leaves the system, ensuring privacy while maintaining flexibility. Payload provides the content workflow backbone. As a NextGG's native CMS, it manages the brief submission process, tracks project status, and organizes output assets. Teams can customize workflows, set approval stages, or batch process multiple briefs simultaneously. All metadata like captions, publishing schedules, or platform-specific settings lives here, accessible via a clean admin interface. For deeper AI capabilities, Onyx serves as the backend data engine. It powers research tasks like gathering travel statistics for that summer hacks brief or finding trending meal prep topics. Onyx can execute code to analyze data, generate reports, or even create visual artifacts, all while integrating with LLMs for advanced reasoning. If the brief requires up-to-date information or complex logic, Onyx handles it silently in the background. Finally, Grafana keeps the entire system visible and reliable. It monitors processing times, resource usage, and potential bottlenecks, displaying real-time metrics in customizable dashboards. If a video render takes longer than usual or a TTS engine crashes, alerts trigger automatically, letting admins address issues before they affect workflows. Together, these tools form a cohesive, automated studio. Each repository contributes a specific expertise, but the end result feels like a single, unified platform built for teams who need to create content faster, cheaper, and more consistently than ever before. The next step is diving deeper into how these components interact, but first, let's break down the user's journey from brief to final assets. A creator logs into the Payload CMS dashboard and submits a new brief through a tailored form title, key points, tone, and target platform. Payload's REST API ingests this data, creates a database record in its PostgreSQL schema, and emits a project-created event to a message broker like RabbitMQ. Onyx, subscribed to this event, spins up a dedicated AI agent via its MCP-compatible framework. The agent authenticates to Payload's API using a bearer token, fetching the brief's details via GET, the project's API endpoint VID, to initiate processing. Onyx queries its own vector database using agentic RAG, cross-referencing the brief's keywords against stored knowledge bases or pulling fresh data via web search connectors. It generates a script draft, which it refines through integrated code execution, maybe scraping examples or validating facts. Once finalized, Onyx uses its POST, the agent's API endpoint, YID output endpoint, to send the script back to Payload, updating the project record with a script-ready status. Payload triggers the next phase by calling VoiceBox's gRPC service, create voice request, specifying the script text and desired voice profile. VoiceBox authenticates the request, checks its local database for the requested voice model, or clones it on the fly if needed, and processes the TTS generation. It applies post-processing effects like pitch adjustment and exports the audio file. VoiceBox then writes the audio URL to its database and emits a TTS complete event. YumCut, monitoring for media production events, picks up the signal. It authenticates to VoiceBox's API with a bearer token, fetching the audio file via GET, the audio API endpoint lid download. YumCut's Next.js backend then orchestrates video assembly. It generates visuals using its FFmpeg pipeline, syncs the audio, and auto-captions the video. During rendering, it streams progress updates to Grafana via HTTP hooks, logging metrics like frame rate and memory usage. Once rendered, YumCut stores the final assets in a shared object store, like S3 or Minio, and updates its database. It calls payloads post to the project's API endpoint vid complete endpoint, attaching URLs to the video, captions, and clips. Payload updates the project status to ready for review and notifies the team via Slack or email. Grafana's dashboards reflect the entire data flow, from brief submission to final render, tracking latency, error rates, and resource utilization across each service boundary. Each repository handles its domain. Payload manages workflows and assets, Onyx processes intelligence, VoiceBox generates audio, YumCut produces video, and Grafana observes the system's health. APIs and events glue them together, no SaaS handoffs, just clean contracts between self-hosted components. The creator never leaves their dashboard, yet the platform behaves like a single cohesive engine. To bring this automated multi-format content studio to life, we need a practical MVP build order. First, we'll start by setting up the content workflow using Payload, which will serve as the backbone of our system. This involves creating a new Payload project, defining the schema for our content types, and configuring the workflow for creating and managing content. Next, we'll integrate YumCut for automated video generation. We'll use its API to create video projects, upload scripts, and generate videos in various formats. This will involve writing some glue code to connect Payload's content workflow to YumCut's video generation capabilities. For example, when a new content piece is created in Payload, we can trigger a background job that sends the script to YumCut for video generation. To add voiceovers to our videos, we'll integrate VoiceBox, which will allow us to generate speech and clone voices. We can use VoiceBox's API to create voice projects, upload audio files, and generate voiceovers in various languages. This will involve some testing to ensure that the voiceovers are properly synced with the video content. For local development, we'll use Docker to containerize our services and ensure that everything works seamlessly together. We'll write tests to cover the entire workflow, from content creation to video generation and voiceover addition. These tests will help us catch any bugs or issues early on and ensure that our system is working as expected. In terms of background jobs, we'll use a job queue like Bull Queue to manage the workflow. When a new content piece is created, a job will be added to the queue to trigger the video generation and voiceover addition processes. This will allow us to handle a large volume of content pieces without overwhelming our system. Finally, for production deployment, we'll use a cloud provider like Vercel or AWS to host our services. We'll set up a CI/CD pipeline to automate the deployment process, ensuring that our system is always up to date and running smoothly. With this setup, we'll be able to create a scalable and efficient automated multi-format content studio that can handle a large volume of content pieces and deliver high-quality videos with voiceovers. To deploy YumCut, clone the repo, install nodes and FFmpeg, then run npm install followed by npm dev to start the development server. Set environment variables like void API URL for custom backend endpoints. For VoiceBox, install Python 3.10+ nodes and run npm install then npm start. Configure TTS engines by editing the config JSON file to specify models like LuxTTS or Qwen3TTS. VoiceBox is free under the MIT license but requires local machine resources for voice cloning. Payload CMS requires Node.js 18+ and a PostgreSQL database. Initialize with pnpx create payload app at latest t website, then run npm run dev to start. Configure admin settings via the app config folder and adjust environment variables end-to-end for database connections and security settings. Payload is open source under MIT but needs a backend database for full functionality. Onyx deploys via Docker by running Docker Compose up after configuring Docker Compose, YAML with your LLM provider details like OpenAI API keys or local Llama instances. Set environment variables indent for web search APIs, for example serper key, and enable RAG by specifying vector database connections. Onyx is Apache 2.0 licensed but requires technical expertise to integrate with LLMs and connectors. Grafana monitors the stack by configuring data sources in config YAML, such as setting URL for Prometheus endpoints. Install plugins like Grafana World Map Panel via Grafana CLI plugin install. Deploy binary packages or Docker using Docker Run P3000 vpath to provisioning. Etsu Grafana provisioning Grafana latest. Grafana is Apache 2.0 licensed, but needs ongoing maintenance for dashboard optimizations. A developer can start today by cloning YumCut, setting up the user API with a bearer key, and testing video generation via curl, authorization, bearer your key, post. How would you integrate VoiceBox's TTS with YumCut's API to automate multilingual video dubs?